Hi,
I'm
Lily.
and
I'm
Maggie.
and
We're
teaching
you
about
solutions.
Yay!
Let's talk about properties of solutions. So the first thing you need to know is what a solute, solvent, and solvation is. A solute is the material that is dissolving. A solvent is the substance that the solute is dissolving in. The solvation is the process in which negative and positive ions become surrounded by solvent molecules. Got that? Good job. The next one you need to know is homogeneous versus heterogeneous mixtures. A homogeneous mixture is a mixture which has uniform composition and properties throughout. A heterogeneous mixture is a mixture that does not have uniform composition and properties throughout. So, you might be wondering, what affects solubility? Well, let me tell you. There are three things that affect solubility: agitation, temperature, and particle size. Let's talk more in depth about the effects of solubility. So with agitation, an example of this would be stirring. Like if you put salt in water and you start stirring, the salt will dissolve. You can try this in the dining hall at any time. The other effect is temperature. With gases, it is less soluble at high temperatures, and with solids, it's more soluble at high temperatures. With particle size, the smaller equals easier to dissolve due to a decrease in surface area.
In addition to that, you need to know the solution process. First, you need to know the difference between a saturated, unsaturated, and supersaturated solution. A saturated solution is when the maximum amount of solute is dissolved at a constant temperature and pressure, meaning that it's at a state of equilibrium. An unsaturated solution is a solution in which the solute concentration is less than its equilibrium solubility. A supersaturated solution is when there is more solute than the solvent can hold at the given temperature and pressure. I hope you got that, because I'm not going to repeat myself. You also need to know the difference between something that is miscible and immiscible. Something that is miscible is when there are a pair of liquids that can dissolve in each other in all types of proportion. Something that's immiscible is when two liquids are insoluble in each other, just in general. So I hope you got that, because again, I'm not going to repeat myself. Okay, so now we're going to talk a little bit about molarity. The formula for molarity is molar, represented by big M, is equal to the moles of solute over liters of solvent. And so, in order to try and fully understand this, we're going to do a practice problem. So the problem is, 1 liter of seawater contains about 28.0 grams of NaCl, or as you know it, salt. If you have 1,000 milliliters of seawater, what is the molarity of salt in the seawater? And so, to do this, first you're going to convert the grams of salt given to the moles. And so you're going to multiply by 1 mole over the molar mass of salt so that the units cancel out and it leaves you with moles of salt as your unit. Then you're going to convert the milliliters of solvent to liters. So you're going to take 1,000 milliliters and then multiply it by 1 liter per 1,000 milliliters. And the units should cancel out for milliliters, leaving you with your answer of 1 liter of seawater. Lastly, you're going to plug it into your formula, and you're going to get M equals 0.479 moles of salt over 1 liter of seawater. Get your final answer to be M equals 0.479 molar.
Okay, let's talk about dilution. So, when you approach a dilution problem, you need this formula. M1 V1 equals M2 V2. M equals molarity and V equals volume. So now we will travel over here to talk about an example. Let's read the problem. Commercial nitric acid is about 15.4 molar. What volume of commercial nitric acid must be used to prepare 5.00 liters of 6.00 molar nitric acid? Let's find out. So, as we have seen over here, we are using the same equation. So our M1 is going to be 15.4 molar times V1, which is our variable that we were looking for, and 6.00 molar is going to be our M2, and 5.00 liters is going to be our V2. So in order to isolate the V1, you want to divide the 15.4 molar from the 30.00 milliliters. So by doing that, the molars will cancel out, and you are left with V1 equals 30.00 liters over 15.4. And your final answer is V1 equals 1.95 liters.
Go.
Another thing you need to know how to do is mass percent, which is a method that expresses the concentration of a substance in a mixture or element in a compound. So let's go over to real life examples. So how do you find the mass percent of carbon and oxygen in CO2? Well, first you need to identify on the periodic table what the masses are. So to find the mass percent of carbon, you times 100 times 12.01 grams of carbon, which is the molar mass, over 44.01 grams of CO2, which is the molecular mass of CO2 when you add them all together. And this equals 100 times 0.2729, which comes out to 27.29% of carbon. To do oxygen, you do something similar. However, since there's 1 mole of carbon to every 2 oxygen, there's a 1 to 2 mole ratio. So you need to times 2 by 16 grams. So for oxygen, you would do 100 times 2 times 16 over 44.01, which would equal to 100 times 0.7271, which would result in 72.71% of oxygen. And also, after you finish doing all that, you should always check to make sure that everything adds up to 100. This is the easiest way to make sure to look at any errors that you have made or if you have done everything correctly. And we have done everything correctly, so we are good. Now I know by now, your brain must be exploding with knowledge. But bear with me as I talk to you about electrolytes. An electrolyte is a compound that conducts electricity when in an aqueous solution or molten state. A strong electrolyte is when nearly all ions exist in the solution. A weak electrolyte has few or barely any ions existent in the solution. A non-electrolyte is a compound that does not conduct electricity while in an aqueous solution or molten state.
You also need to know about colligative properties. Those are properties that are affected by the presence and amount of a solute, and there are 3 of them. The first one is vapor pressure reduction. That's when solutions have a lower vapor pressure because they have additional forces between the molecules. There is also a higher concentration of a solution because the lower vapor pressure is affected by the greater number of molecules. In addition to that, there is boiling point elevation. That is when the solute increases by the boiling point by increasing intermolecular forces. Last but not least, there's freezing point depression. That's when the solute prevents the water from making a solid structure. Got it? Good. Okay, so now we're going to talk a little bit about solubility rules. Here is a little clever acronym that you can use to remember them. CASH, N, G, A. So first we're going to start with CASH. The C stands for chlorates. The A stands for acetates. The S stands for sulfates. And the H stands for halogens. Now, for both the S and the H in CASH, we have a few exceptions. So these are the exceptions. For sulfates, calcium, barium, strontium, mercury, silver, and lead will not be soluble. And for halogens, mercury, silver, and lead will not be soluble. Okay, let's go back to our lovely acronym. The N stands for nitrates. And then last but not least, GIA stands for group 1A.
Let's talk about net ion equations now. So the point of net ionic equations is to isolate the ions that primarily exist as ions in an aqueous solution. In order to do these, you need to know the solubility rules. Okay, here's our example. So the first thing you're going to get is an equation. And the number one thing you want to do is to see that if it's balanced or not. If it's not, then your whole thing is going to be messed up and you're going to do all this work for nothing. So, this thing is balanced because we checked it. And we already put down which ones were aqueous and solid because we're, again, very smart. So then the next thing you want to do is to split the compounds into ions that are aqueous, and you're going to get this as a result. Then you are going to want to cancel out the elements that are the same on either side. So 2K plus will X out with 2K plus over there, and 2NO3 minus will cancel out with 2NO3 minus over here. These are called the spectator ions. When writing the spectator ions, you do not need to include the coefficients. So since this was 2NO3 minus, you only have to write NO3 minus, and instead of 2K plus, you would write K plus. So your net ionic equations would not include those, and they would end up being A2 plus aqueous plus SaSO4 2 minus aqueous to BaSO4 solid.
Make sure you balance that.
You need to know the definition of anhydrous and deliquescent. Anhydrous is when substances don't contain water. Deliquescent is when substances remove water from the air to form a solution. Okay, there you go.